My name is Paul Grosse. And my entire career, I dreamed as a 7-year-old of being a Channel 4 weatherman. And so, I grew up to be what I wanted to be when I was 7 years old. So I've actually worked here for 38 years. I'm the dean of TV meteorologists here in Detroit. And I guess that means I'm old. And let's see, what else can I tell you? I've been named a fellow of the American Meteorological Society. And I'm one of only 6 meteorologists in the world that has been named a fellow of the AMS and also an AMS certified consulting meteorologist and certified broadcast meteorologist. So to have all 3 of those is actually quite rare. And it's just a great honor to be in that position. Love history. So I've done a lot of historical research, a lot of it involving weather and its impact on history. And the last thing I'll mention is that I've been qualified to testify as an expert in meteorology in court. So I've actually testified in almost 4 dozen trials as an expert in meteorology, providing information that helped to resolve lawsuits. Well, there's an old saying that climate is what you expect, weather is what you get. And that really is, in a way, quite true, because we all know what the weather is. I mean, you step outside and you experience the weather, and that can be sunny, windy, hot, cold, stormy, dry. It can be anything, humid, dry. So the thing is that in order to get some perspective as to what is considered average for any particular day, week, month, or year, what we do is we then take weather statistics over a certain period of time and average those together. Okay, so in some cases, just to see what our average daily high is, what climatologists have chosen is a 30-year period. So for example, if I was to tell you that today's record high was a certain temperature, that would be a record high, that over the entire period of record, that would be the highest it's ever been. But if I were to tell you what the average temperature is for a particular day, that is the average over a 30-year period. And that's the previous 3 complete decades. So every decade, they compute a new set of averages, and they just move it a decade, forward in time to get you closer. So that is how we get a perspective on what is considered abnormal or normal weather. And that is by averaging things out over periods of time. Again, sometimes it's over a year, sometimes it's for a month, sometimes a week, sometimes just a day. But by averaging that all out, we then get perspective as to a particular weather event and just how extreme or not it is. There are some thermometer readings that go back into the 16 and 1700s, but if you're talking about more of a global data set, we go back into the mid to late 1800s. So 1870 or so is 1860, 1870, 1880 is really a good period to try and start actually looking at global data sets for things like temperature and precipitation. When we look at the globe as a whole, and that's why I actually prefer the term global warming. I know a lot of people say, well, that's not a politically correct way to say it. You should call it climate change. I actually use the terms interchangeably, but I prefer global warming because it is a planetary warming. We are seeing a very unnatural warming of our planet's climate. And this has become especially noticeable, almost exponential, over the past 50 or 60 years. We're really seeing a sharp increase in the rate of temperature climb over especially the past 50 or 60 years. But really, it was something that began with the Industrial Revolution. Something that people really don't understand is that humans have actually changed the composition of our planet's atmosphere. When we started mass producing in factories and putting a lot of pollution up into the atmosphere, what that did is it introduced a lot more carbon dioxide to the atmosphere. And also there are other gases as well. There's nitrous oxide and there's methane as well, which are very important greenhouse gases. So as humans started putting more of those into the atmosphere, the response has been a warming. And I will say one other thing that maybe will put this in a better clarity for you and others, and that is that if you take any planet, that planet's going to have an average temperature. That temperature is based on 3 primary things. One is how far is it from its star, in our case, the sun. Number 2 is its surface albedo, or another word for that is its surface color. So in other words, darker colors, you know that in the summer, if you wear darker colors, you feel hotter. That's why we tell you to wear like white or lighter colors in the summer. That reflects more of the sun's radiation. So the planet's proximity to its star and its surface color, those are 2. The third one is the composition of its atmosphere, because whatever makes up that atmosphere, there are certain gases that trap heat. Okay. And so when the Industrial Revolution began, we increased those gases. And the other two things have not changed. The Earth has not gotten really any closer or farther from the sun, and the sun itself hasn't changed enough to do anything to our climate, and our surface color hasn't changed. So that leaves you one thing left, and that's the composition of our atmosphere. So as a result of our changing the actual composition of our planet's atmosphere, that's why we're seeing this warming. And to answer one other question that a lot of people have, it's like, well, how can humans, we're just a small part of this planet, how can humans actually make that big of a change? And what I will do is tell you, think about if you make an omelet and you go and you sprinkle a little pepper on that omelet. Think about how little pepper you put on that omelet and how big of a change in flavor that is for you. So that's kind of an analogy that helps maybe to understand that, yes, even though humans are maybe a small part of this planet, we have actually made enough of a change to our atmospheric composition to actually change our climate. It's what people want to know. They want to know, how is this warming affecting my weather? And it is affecting the weather, and it is affecting other things that have a very tangible importance to people. So, for example, we're seeing more hot temperature extremes and fewer cold extremes. That doesn't mean we don't get any cold extremes. Like in this past mid-February, it was very, very cold for a short period, but most of the winter was milder. And we have actually seen that our winters are getting milder overall. In fact, winter is the fastest warming season of the 4 seasons. So we're actually seeing it most manifest in winters. And in the summer, we're not only seeing it in the way of heat that may be experienced in the afternoon, but we're seeing it in overnight lows. Okay, overnight lows are warming faster than daytime highs. And so that's important too, because when you get a heat wave, for example, people without air conditioning, that nighttime cooling is what gives you a chance to recover from that hot daytime temperature. So if the overnight lows are getting warmer, that actually makes heat waves worse as well, because that's less recovery time. So that's one tangible thing right there. We're seeing a change to our growing season in some respects here. Okay, with winters getting warmer, we're seeing a longer growing season, but that's not necessarily a good thing for 2 reasons. First of all, if you have some early season warmth and it gets so warm that our fruit trees start blooming and the fruit blossoms start coming out, but you still get a killing freeze, say later in April or in May, then you can kill those blossoms and ruin the crop. And that happened in 2012 and it happened in 2002. Both of those years, we had early spring warm-ups that brought out the cherry blossoms, not to mention other fruit trees here in the state, and that we lost most of the state's entire tart cherry crop those years. So that's one thing. By lengthening the growing season, an earlier start is not necessarily better, because you could get that killing frost that then causes problems. But there's another thing, and I'll ask you and everybody watching, raise your hand if you have allergies. Okay. So one, if you have a longer growing season, that means that pollen producing plants are going to have a longer season. So that means you have a longer allergy season. But wait, there's more. The extra carbon dioxide in the atmosphere is also causing pollen producing plants to produce more pollen. So future allergy seasons are not only going to be longer, but they're going to be more intense as well, because the plants are producing more pollen. There's more pollen out there for you to be exposed to. So those are just a couple of very tangible ramifications of the warming that we're seeing. Absolutely. We are seeing an increase in extreme precipitation events, both rain and snow. And I'll talk about snow in a second. But in terms of rainfall, this is a real easy one to explain. When you warm the planet, more ocean water evaporates into the atmosphere. That's called atmospheric humidity. That's an increase in atmospheric humidity. That atmospheric humidity is what storms use to produce precipitation. So these big storm systems that we get, those now have the potential to drop more precipitation. So we're seeing an increase in intense rain events. Listen, for those that remember, we had that great flood of August 2014 here. That was a once every 500-year rain event or 200-year rain event, something like that. It was extraordinary. And we've had others since then. And in fact, I have some colleagues and friends that work in Houston, and they were telling me recently that they have had 4 1,000-year rain events in the past 4 years. So think about that. In Houston, a rain event that used to be considered a once every 1,000-year event has happened 4 times in the past 4 years. So these are the types of things from a rainfall standpoint that we are seeing. We're seeing an increase in the high-end rain events. But snowfall, now that's an interesting one as well, because again, these storm systems are also winter storms. And if we get on the right or wrong, depending upon which side of the fence you're on, the right or wrong side of the storm track. So let's say that storm track in the winter is near Michigan. We're seeing more snow being dropped from these storms. So for example, that winter, that polar vortex winter of 2013, 2014, we also had almost 95 inches of snow, the most snowfall we have ever had in Detroit. And in fact, just in the past 20 years, we've had 5 of Detroit's top 10 all-time snowiest winters. So think about that. In a warming climate, a rapidly warming climate, we have had 5 of our top 10 snowiest winters just in the past 20 years. That's, again, because of that increased water vapor in the atmosphere. These big winter storms are dropping more snow. Let me just jump in with something. A way to maybe explain the more extreme storms and extreme weather events that we're getting would be to use the steroid example. Now, if you're familiar with what happened in baseball, you had some baseball players back in the 90s that took steroids and they got bigger and stronger. And these guys were hitting record amounts of home runs. Okay. Now, these guys were great baseball players before they started taking the steroids. They hit a lot of home runs before they took the steroids. But what the steroids did was made them stronger. So they were hitting the ball a little farther. And some of those balls they hit that might have been long outs, maybe caught right on the warning track or near the wall in the outfield, some of those were now going out for home runs. Okay, so they were hitting more home runs. What we've done by increasing the greenhouse gases in the atmosphere is we have put our atmosphere on steroids. Sure, we've had big storms in the past. We've had incredible storms and incredible rain events and incredible snowfalls in the past. But the problem is that we're now priming the atmosphere and making it more predisposed to give us more of those type of events. So it's just like the baseball player. They hit home runs before the steroids. We had big storms before we started increasing the greenhouse gases. But what's happening now is we're getting more of them now, just like the baseball players hit more of those home runs after they started taking the steroids. There is a lot that people can do to help. And some of it is very easy and costs nothing. Some of it is something that you have to spend money for, but it just depends how much you want to do. So first of all, starting at the easy end of the scale, power companies, most of them put, with coal burning power plants, a lot of greenhouse gases into the atmosphere. So this is a simple one. The less electricity you use, the less power they have to generate. That means the less greenhouse gases they put in the atmosphere because they're burning less coal. So for example, if you're going to be leaving a room, for example, for 20 minutes, half an hour, turn off the lights. Don't leave lights on in rooms that you're not going to be in. Other things like we tell people in the summer, dial up your thermostat a couple of degrees. In the winter, dial it down a couple of degrees. I have a programmable thermostat at my house, or I have it programmed to do just that for me. When my wife and I are not at home because we're at work, it dials that thermostat down to like 65 degrees. And then just before we come home, dials it right back up to like 68, and we're comfortable. So saving on the amount that your furnace runs, that again, it saves electricity. Okay. So things like that are real important. And then in terms of, maybe ratcheting up a little bit, driving a more fuel efficient car helps, because the better your gas mileage, the less gas you're burning, and that's less emissions that are coming out of that tailpipe of yours. So a more fuel efficient car. I practice what I preach. I drive a Chevy Bolt. It's an all electric car. I just plug it in every night, and then I have a full charge the next day, and I drive to work. And I haven't been to a gas station since, I think a little over a year now. And so, I mean, it's great. So now granted, the car is more expensive, but then I'm also saving money in gas. Now that's being offset by more electricity I'm using at home, but there's a trade-off, and still the electric car does get you come out ahead in that. Now, other things people can do, and this gets now into spending a lot more money, but some people are putting solar panels on their homes. I mean, my synagogue right now is actually in a research project right now investigating to whether to see if it's viable to put solar panels on the roof of our synagogue and save our to shrink our carbon footprint. So that's something that people can do. Again, now, there are levels of how much you want to spend to do this, but some of the things that, are just easy. Just don't waste electricity.
Awesome.
Probably the biggest thing is that this issue has become a political issue, and it's very sad that that has happened. Climate change is a science, and politicians are policymakers. So in an ideal world, what happens, and this is the way it used to be, scientists, whatever discipline, scientists would develop research conclusions or whatever, and then there was a way of communicating that to the Congress. And then there would be committees that would meet and they would develop policy, and then they would bring these up for votes, and policy would be created based on what the science community was telling them. But now, because of the very sharp, deep political divide, you have some people in Congress that flat out deny verified science. And they have to understand that the scientists, most 99.9% of the scientists have no agenda. They just do their research, and the research is what the research is. But the fact of the matter is that there are almost no papers. In fact, the term I'm going to quote from one article, vanishingly small is the number of research papers being published that are opposed to this global consensus among the climate science community. Over 97% of climate scientists in the world agree that the planet is warming unnaturally and that humans are the proximate cause. The reality is that the scientific community is almost unanimous in the conclusions about what's happening. So I'll give you one more analogy that I use with people, and that is, let's say you look in the mirror in the morning and you see a little lesion on your ear. And so you go to your doctor and the doctor says, I think that's a melanoma. I think we better cut that out. But you say to the doctor, no, I want to get 99 other opinions. So I want to have 100 opinions from doctors telling me what this is and what I should do. So you go to 99 other doctors. And in the end, 97 of those doctors say, I think it's a melanoma. You better cut it out. And 3 of those doctors say, I think there's enough uncertainty that we should wait and let's see what happens. But I would say that 97% or greater is a pretty high percentage. And by the way, I don't support some of the radical solutions that some people in Congress are supporting. I'm not just, Mr. Blank Check, we got to just do it all immediately for climate change. What I am is there are things that we need to do to slow the warming, because we're past the point of stopping it right now. We need to slow the warming. Okay? So what we need to do is slow the warming, because that then buys time for certain species of plants and animals to perhaps adapt or migrate, and it buys time for humans to mitigate. But if we leave things unchecked as we are right now, some of the changes are going to happen so fast that then it's going to be a negative impact on all species, most species. So that's the key takeaway, is that we need to do things that slow the warming, because it is too radical to say that we have to just stop it right now, because we can't just stop it on a dime. The science of global warming is not a new science. There were scientists back in the 1800s who were already proposing theories that if you increase carbon dioxide in the atmosphere, that will increase the planet's temperature. So this is not new. This is a science that has been developing since the 1800s. So it's not just some recent political stunt by somebody. This is science that has existed since the 1800s. So a lot of people are concerned about rising sea levels with the warming of the climate. Now, first of all, the Great Lakes are not going to be impacted from the overall sea level rise. The Great Lakes, we are impacted in terms of our lake levels from snowfall in the winter and then that resulting snowmelt in the spring. So it's precipitation that really does it for us. But ocean water, that's different. And what most people don't understand is what causes the sea level to rise. Okay. Now, about 2/3 of it is from melting glaciers. Now, for example, let's say somebody says to you, well, the North Pole is melting and that's going to rise sea levels. Well, that's actually a false statement, because all of the North Pole ice is actually already in the water. So it has already displaced its volume in the water. And the best analogy for that would be if you have a glass of ice water on the counter, you have it filled to the top with water and there's ice in there. When the ice melts, the water doesn't flow over. The water stays in the glass because the ice has already taken up its space in the water. So when it melts, it just changes from ice to water. So that's why the North Pole ice is not going to cause sea level to rise. What will cause sea level to rise, for example, is the melting of the Greenland ice sheet. That ice is on land and it is melting, and that is flowing into the ocean. And same thing with Antarctica. So as those ice sheets melt, and if they melt, according to the projections that some people say it will do so, you're going to see very large sea level rise, but that's only 2/3 of it. You know what the other third of sea level rise comes from? It comes from something called thermal expansion. Water is a very interesting substance. When you warm water, its volume expands, okay? So just the fact that the oceans are warming, that by itself is 1/3 of our sea level rise, because as the oceans warm, and they are warming very rapidly, the ocean warming is causing some of the sea level rise just by itself. And so sea level rise, maybe you don't care living here in Detroit, or somebody in Kansas doesn't care, but if you live on a coastline somewhere, you should care, because I've already seen some inundation maps which show that places like Miami and places like New York and Boston, those coastlines are gonna change. That water is gonna come farther inland, and keep in mind that's salt water. So anything that is a crop, like especially in Florida, that salt water kills those crops if that comes inland. Okay, so there's another ramification. So let's say you have a hurricane. Okay, you know what storm surge is, the part of the hurricane where the wind is blowing toward shore, it's pushing water ashore. Well, if that water is now starting off at a higher level, that storm surge is going to go farther inland. So that's going to make one aspect of hurricanes different and worse. People ask about tornadoes and about hurricanes, and so I'll maybe briefly mention those. Yeah. As far as the warming climate's impact on tornadoes, it's a little uncertain, but right now the prevailing thought is that while we may see fewer days in which there are tornadoes across the country, we may see bigger individual tornado outbreaks. So I'll leave that up to you to decide as whether that's good news or bad news. So fewer days with tornadoes, but bigger outbreaks with maybe more severe tornadoes. That's, again, which is better, which is worse. That's up for you to decide. But that's because of the storm systems becoming stronger. That would create a situation with bigger tornado outbreaks. But again, some of the scientists think that there'll be overall fewer days with tornadoes. And as far as hurricanes, it's actually a similar story. If you warm the ocean temperatures, well, that's fuel for hurricanes. So the future of hurricanes very well could be a future of fewer hurricanes, but more intense ones, because the ones that do develop in favorable conditions are going to be developing over warmer ocean waters, which would make them stronger. So really, it's kind of a similar story with tornadoes and hurricanes. Right now, the prevailing thought, and there's still research to be done, but the prevailing thought is that our future will be one of perhaps fewer days with hurricanes and tornadoes, but bigger tornado outbreaks individually and more intense individual hurricanes. One other physical impact of the warming that people will care about is that it's causing some species to migrate. So for example, as river waters warm here in the state, cooler water loving fish are starting to migrate northward. There are other species that are migrating one way or the other because of the changing in their habitat due to the warming of the climate. So, for example, I heard one person say that 50, 60, 80 years from now, buckeye trees from Ohio might migrate and start growing in Michigan. And I'll be darned if I allow a buckeye to grow in Michigan.
My name is Lauren Fry, and I'm a research physical scientist at NOAA's Great Lakes Environmental Research Laboratory in Ann Arbor. I lead research related to Great Lakes hydrology there, and I've been there for about a year now. Came there from the Army Corps of Engineers, where I led water level forecasting activities. Yeah, so right now, as anybody who lives along the Great Lakes knows, that water levels are really pretty high right now. We've actually seen a pretty dramatic surge since about 2013 on the Great Lakes. It's been a pretty dramatic shift for people because it's coming at the tail of a very long period of low water level on Lake Superior and Lake Michigan Huron that actually ended in record low water levels on Lake Michigan Huron in at the end of 2012 and the beginning of 2013. And so since then, we've kind of seen an upward trend, especially until last year. All of the Great Lakes set new record high water levels in either 2019 or 2020, or both, depending on the lake. And those records are relative to a period dating back to 1918. So it's just a little over 100 years. It's kind of a neat story about international collaboration, binational collaboration between the US and Canada. There are gauges on the Canadian side of the border that are operated by the Canadian Hydrographic Service. And on the US side of the border, NOAA operates gauges throughout the Great Lakes. And there's a coordinating committee for Great Lakes data that actually takes the gauge data from both sides of the borders to compute lake-wide average water levels. And so whenever you see data that's reporting record high, record low, average lake-wide average water levels, those would be coming from this set of gauges that's operated by the US and Canada. And so a lot of care is taken between the two countries to make sure that we're gathering good data and using good statistics on those data. Over the past several years, we've really seen very wet conditions, really starting, back when we started to see that rise in water levels. For example, the 5 years ending in December 2019 were the wettest 5 years on record for the Great Lakes Basin. So really persistently wet conditions. Up until really right now, we haven't seen the wet conditions this year, but up until very recently, we've had persistently wet conditions, which is the primary driver of recent water level trends. Overall, water levels are driven by a combination of the precipitation that comes over the lake, the evaporation that comes off the lake surface, and the lateral tributary runoff that flows from the land surface into the lake. So those three things combine together, and we call that the net basin supply. So that net basin supply is really what makes water levels go up or down, depending on, if we have very high supplies, then we'll see water levels go up. But overall, those high supplies in recent years have been driven by excess precipitation. You asked about ice cover and evaporation, and actually the relationship between ice cover and evaporation is fairly complex. I think we tend to think of evaporation acting as a cap or ice as a cap on evaporation. And really it's much more complex than that. When you have ice forming, that's actually a period of dramatic evaporation. So evaporation rates are highest when you have cold air coming over relatively warm surface water. So I guess if you think about the seasonal pattern of water levels, that helps explain it. Water levels go up in the spring when you have a lot of runoff coming into the lake and increased precipitation. Then during the summer, you actually have a lot of energy transitioning, warming the water. And that's important for the fall, because then in the fall, we have pretty warm surface water temperatures. I mean, they may not feel warm if you're swimming in them, but they're warm relative to the air that then comes up, you get those cold blasts of air coming from Canada that really result in evaporation. So if you think of like a hot cup of coffee on a cold day, you see that evaporation. It's that same phenomenon. On the other hand, in summer, if you have cold water and a warm air, think of your cold glass of ice water and you see condensation. So really evaporation is most important in the fall. And early winter if we see cold blasts of air coming in. And we actually did see increased evaporation rates in this past winter, because if you remember, we had a pretty warm fall and early winter, and then we had those cold snaps in February. There was some enhanced evaporation during that period. Yeah, that is a question that comes up a lot, and I'd like to say I have an easy answer. If you think about the ocean coasts where water levels are rising, we know that. On the lake coasts, we have to consider the interplay between increases in precipitation and also the potential increases in evaporation, depending, how those interplay. And so, depending on the regional climate, we could see water levels go up or we could see them go down. What we do anticipate is that we will have more high water levels and we will have more low water levels. And we think maybe the variability of those water levels will change. So looking, far out into the future, I think it's just most important to be prepared for both high and low conditions. I think it is very important. You said it right there, to think of the Great Lakes as a system. So, for instance, Grosse is on the Detroit River. The Detroit River flow depends on the lake level on Lake Michigan Huron and the lake level of Lake Erie and Lake St. Clair in between. So, if you have water levels go up on Lake Michigan Huron, that's going to potentially result in increased outflows through the St. Clair and Detroit rivers. But likewise, if you have an increase in Lake Erie, that difference in water levels is going to change the amount of flow. So we really do have to think of it as a whole system. And it's really Mother Nature that's driving the water levels. It's that combination of precipitation, runoff, and evaporation that's driving lake levels on the whole in the Great Lakes. I think that it's important to think about what you're doing on a daily basis. Think about whether you need to adjust how you travel, that potentially make changes in, your little changes in your everyday lifestyle that could potentially result in big changes if a lot of people do it.
Awesome.
Yeah, I think, it's really exciting that we have a Great Lakes Research Laboratory in here. That's part of our research arm of NOAA. So that's a pretty exciting thing to have here in Michigan. And, NOAA does play an important role in Great Lakes activities. I talked about the water level gauges that NOAA operates, and working collectively, with the federal agencies on both sides of the border to study the Great Lakes. So there's certainly a lot of resources that NOAA provides to the Great Lakes.
My name is Erin Rowan, and I'm the Senior Conservation Associate with Audubon Great Lakes and Michigan DNR, and I'm based out of the Metro Detroit area. So I manage the MI Birds program, or Michigan Birds program, which is an outreach and engagement program founded by Audubon Great Lakes and Michigan DNR back in 2016, which aims to increase all Michiganders' engagement in the understanding, care, and stewardship of public lands that are important for birds and people. So we do that a few different ways. We have a strong social media presence and do a lot of outreach and education on bird conservation topics across the state. We typically, pre-COVID, run in-person programs as well on public lands, including guided birding tours, but also some stewardship days. We hope to get those started again, maybe by the end of this year. And now, due to COVID, we have switched over to doing some virtual programming. So we have a series of webinars, and our blog has been somewhat revitalized as well. So we're posting more content more frequently, hoping to engage Michiganders in different community science and volunteer opportunities across the state. And then, in addition to the My Birds program, I'm also involved in a few on-the-ground conservation projects in different parts of the state, including habitat restoration, primarily of coastal wetlands at places like St. Clair Flat State Wildlife Area and Ottawa Sands, County Park, which are both important bird areas. We also are doing some work up at Wigwam Bay State Wildlife Area, focusing again on wetlands and secretive marsh birds, which have seen really big declines across the Great Lakes. And we have boots on the ground now in 4 of our priority regions in Michigan, which is great, either in the form of volunteer community science and bird monitoring, or some combined habitat work. Yeah, so Audubon back in the fall of 2019 published their Survival by Degrees report, and this study showed us that a vast majority of our birds are at risk of extinction due to climate change in North America. So that includes over 300 species. And if we are seeing warming at 3 degrees Celsius, we risk losing 2/3 of those species. But if we're able to keep that warming at 1.5 degrees Celsius, we can limit that and save 76% of those species at risk. Here in Michigan, that means we have 55 highly vulnerable species to climate change that have a risk of extinction in the state at that 3 degrees Celsius warming scenario. But again, if we're able to limit that warming to just 1.5 degrees, we'll save a majority of those and only have 6 species that would then be at high climate risk. But birds are impacted by climate in so many different ways. We have one aspect of the Survival by Degrees report that was really unique was that our researchers also looked at 9 climate threats that impact both birds and local communities. All of those 9 climate threats can really impact the success of our breeding birds here in Michigan, where they can nest, how successful they can rear their young up to fledging, which is really important for sustaining populations. But then also it impacts everything along their life cycle. So not just while they're here in Michigan, but during their migration route and on their wintering grounds as well. We're seeing that climate change is impacting the timing as well of when habitat and food sources become available for birds. Right now it's spring migration, and there's a growing body of research that's showing that flowering plants are blooming earlier because of climate change, and there's potential for this change to impact the established synchronous relationship between birds, particularly hummingbirds like our ruby-throated here in Michigan. And they're also being seen arriving earlier along with those flower blooms. So it's something that is still somewhat poorly understood as far as tracking these changes and shifts, but due to our research and our modeling, it looks like a lot of these birds are going to be losing a majority of their range, their typical range. Particularly sensitive to things like false springs include our hummingbirds because they rely on nectar for up to 90% of their diet. And if a false spring occurs, they can't access that very easily when it's frozen. And the other 10% of their diet is supplemented by insects, which also go dormant in these colder temperatures. Another species, which also primarily eats insects, is the black-throated blue warbler, but they also supplement their diet with fruit on their wintering grounds. But because of that, it's allowing them to migrate a little earlier as well, similar to hummingbirds, because they can supplement their diet with fruit if there is still fruit available. Other insect-reliant species like warblers, swifts, and swallows can also be greatly impacted by false springs. False springs are also particularly harsh as birds can be killed by these unseasonably cold temperatures. And a lot of migratory songbirds are not very well adapted to those cold temperatures, which is why they leave Michigan in the winter. So the scarlet tanager is a great example of that. They are not built to handle these colder temperatures. So if we have a false spring where we have these unseasonably warm temperatures followed by a longer cold snap, it can really be detrimental to a lot of bird species that we really love here in Michigan. Yeah, so when bird ranges are shifting farther north, there's a chance that the habitat that they require might not be there yet. So it's something that could really, again, put those birds at high risk of not getting what they need to survive. So that is why there is a growing concern for birds being lost. And some vegetation is also adjusting and shifting. We've seen some things moving upslope in mountain habitats. We've seen other plant communities starting to shift north as well. But it's likely not going to occur at a rate that we might see birds getting pushed farther north. So that's the area that we still are hoping to learn more about. Change is impacting birds greatly, and they're always that canary in the coal mine. And so how they're impacted and what happens to them really has a lot of implications for how our own communities are going to be impacted. And we're already seeing this these last few years with our ever breaking water level records, where we're seeing communities, at risk of flooding. We're seeing a lot of water quality issues as well because of habitat loss and degradation. And climate change plays a role in that as well. So with climate change, we have, at least here in the Great Lakes in 2013, we had like that record low water level year, and now we're bouncing to the other end of that extreme with record highs. And it's greatly impacted the ability of some invasive plant species to move in and dominate certain landscapes. And then equally made it difficult to manage those species and try to remove them in these higher water level years now. So they've really establish themselves. And then other things that contribute to climate change that we might not think about is things like land use conversion. When we lose habitat, it's not great for birds, but it's also not great for climate change because that habitat is doing things like storing carbon, cleaning our air and our water, and providing all of these great natural processes, great natural processes that really benefit our communities too. So just keeping that in mind and knowing that birds are that indicator species for us, and they're really telling us that something is off, and it's really important for us to pay attention to that and do what we can to limit impacts. I encourage folks to get involved with bird conservation in their local communities. If you're interested in learning more about volunteer opportunities, stewardship days, and community science, I encourage folks to follow the My Birds program, MI Birds. You can find us online at Facebook, Instagram, and Twitter, but also visit our website at gl.audubon.org/MI Birds. I also encourage folks to participate in opportunities to have public input on current land management strategies. You have an opportunity to voice your concerns with any current public lands management and master planning processes. So it's a opportunity to make sure our land managers know what's important to you. And I also encourage folks to speak with their legislators about any of these issues that are important to them regarding bird conservation.
Today, I'd like to talk a little bit about Michigan native plants. I started about 4 years ago getting really involved in these when I realized I had no pollinators to speak of in my garden. And I started buying some native plants and watched the butterflies return and watched more bees return and so forth. So I'm going to feature a few of these that you may not have in your garden, but might want to consider getting. The first one I'm going to talk about is Rudbeckia laciniata. It's cutleaf coneflower. This one can get 7 feet tall, but it's a great background plant. I was one of the first plants I put in my circle garden in the center. And within 2 days, the bees and butterflies were on it, and it was in the middle of a field. So they found it somehow, and the pollinators were there. It's just a delight to see. So I'm very happy with this plant. And it's so sturdy that you do not have to stake it. that I was surprised about because some of them are not that sturdy. This one is. This is Golden Alexander. This is a member of the carrot family, and it is a host plant for the black swallowtail butterfly, which is a Michigan native butterfly. It does attract some pollinators. It gets a little gangly, but I like it anyways. It blooms pretty much through the summer, and it attracts a few pollinators. I love this plant. When I saw it in the catalog, prairie smoke. I love the little smoke here. And when my first plants bloomed after I planted it, I got this, and I'm going, oh no, I didn't get the smoke. But the flowers open first and the smoke comes later. But this is just such a cool plant, and it is a short plant. It could be used in the front of a garden. And I haven't seen that many pollinators on this one. It does say it attracts pollinators. I'll be watching this summer to see what I get. This is scarlet bee balm. For those of you who have grown bee balm, a lot of the pretty colors that you can get from the garden centers, one of the problems you have with that is the powdery mildew. And this one here is powdery mildew resistant. I grow it both in shade and in sun. It does equally as well. This one's in shade and these two are in the sun, and the flowers, it's one plant. And neither one had any powdery mildew. So this one is quite powdery mildew resistant, and it is quite variable in terms of what you can grow it in. So it is a member of the mint family, so it does spread. So you want to make sure that you have a little room for it to move on out. And of course, there's swamp milkweed. A lot of people talk about the monarch butterflies and having host plants for the monarch caterpillars and so forth. The swamp milkweed is very desirable because it doesn't spread like the common milkweed does. They have the runners that go underground and can pop up 3 feet away. So this one here pretty much stays in little clumps. So here's some of the plants. I grew these from seed, and they actually bloomed in the same year that I grew them from seed. But I started them early indoors, and I had caterpillars everywhere I wanted to look. So this one's a great plant for that. It also, the flowers are attractive to a variety of butterflies, mostly butterflies that I've seen on those. And this one here, clustered mountain mint. This actually is my favorite plant in my garden for native plants. This one I counted, I photo documented my pollinators last year. I counted the pollinators on this. I had 14 different pollinators at the same time on these plants. This plant is actually very amazing, and it attracts pollinators and it smells wonderful. It's also very pretty from other mints in that it grows with the green and then comes up and kind of gets a silvery top on it and then gets these little clustered flowers. That's where it gets its name, clustered mountain mint. Because it is a mint, you've got the little runners, so you do have to keep those in check. I usually just several times in the season, I'll cut the runners off and keep it in its place, which isn't too bad. So, but this one here, I would highly recommend. It gets to be about 2.5 feet tall. So it is a tall one. It's a bushy one. I haven't had to stake this one either. Bottle gentian. I got this one because of the story behind it. This particular native plant opens like this. They aren't open. The flowers don't open. So you wonder, how do these things get pollinated? Well, they get pollinated by bumblebees with a process called buzz pollination. I never did catch that in action, but I caught the results of it, where they just go in and they buzz the flower open and get the pollen, and then they leave. I saw 3 flowers last year that had been opened up like that. So, and the story was true. That's what happened. Cardinal flower. If you're going to have native plants to attract pollinators, cardinal flower is definitely one of them. This fence here is 4 foot tall. So you can see they do get pretty tall. They do grow straight up. They don't get real bushy. So you might have these more of as a background plant and just put something in front to hide the rest of it. But these are very attractive to hummingbirds because of the fact that they've got the long tubular shape and the red color. Red color attracts the hummingbirds. Northern blazing star. Now, I've had a lot of the blazing stars that grow up straight up with all of the flowers kind of around a single stem. This was a first for me, but the one thing I noticed is that I had monarchs all over this plant. I could go out and find a dozen monarchs on this plant, and I had only 3 plants clustered together, that's all. At any given time, the monarchs preferred this over anything else that I had in my garden when this was in bloom. They really, really like this plant. I'm not exactly sure what's that attractive to it, but it's worthwhile. And it's very pretty with these little kind of a maroon red bracts before the flower actually opens and gets all of the pink on it. So you will enjoy this one if you want to get this one planted. Cup plant. I had never heard of this until last year. Somebody gave this to me as a gift. And the reason it's called a cup plant is if you can see here, the leaves grow across from one another and they form a cup. And inside that cup, and it's kind of hard to photograph, but it collects water. So the birds or the butterflies have like a little reservoir that they can drink from. And I've also read that the plant has that capability to hold the water to prevent insects from crawling up the stems. So it's a kind of a self-preservation thing, and it provides some water for the little creatures. And it also was very attractive to pollinators. Ohio spiderwort. Now, this is a native spiderwort. My experience with spiderworts in the rest of my garden, and I have those, that you buy at the garden centers, and they're all the pretty colors. They tend to bloom and then die back. And then there's a vacant spot in your garden. This one does not. So if you want something that will bloom, it has the most blooms on it are early in the season, and then it stays green and it seems to get a few flowers here and there for the rest of the season. It does not die back. So the native plant is the one you should consider. And it's also very pretty with the flower parts in here. And that's all I have. So if you're interested, I'm with the Michigan Garden Clubs and specifically in growing native plants. You can ask to join this Facebook group. Make sure you fill out the membership questions and we can let you in. And then there's my email if you have any questions. And I also have a Facebook page that you can follow me on if you want to friend me. And go forth and grow. Be curious about these plants. Try some of these different ones that you might not see in the garden. Some of the different Michigan natives. These natives are attractive to native pollinators. Some are the other pollinators, some of the imported pollinators, but that's okay. Whatever attracts them, you need the native plants for the native pollinators. So that's why I started growing them, and I'm so happy that I did. I love watching them buzz around on the flowers. Thank you. Because one of the biggest benefits is once they're established, native plants have roots that they send way down. Some of them can be up to 10 feet down in the ground. If you see these little diagrams that show the different roots that go down. But once they're established, they can withstand drought. And yes, they may shed some leaves if it's really dry out, but they won't pass away. They won't die. They will come back. So that's one of the biggest benefits. And they do, you know, whether they spread from seed, whether they spread from rhizomes or roots or whatever, they will form nice clumps and keep the weeds out. Like especially the clustered mountain mint, you can see there's not going to be many weeds growing underneath that. That one actually was its second year, the picture that I showed you. So, you know, it's just, and of course the ones in the center, the cutleaf coneflowers, I had about 5 stems on the plants when I bought the plant. The second year I had about 20 to 25 stems per plant. I have no idea what it's going to do this year, but it'll be fun to watch. Those are great plants. Don't be afraid to try something different. Yes, I have coneflowers. Yes, I have black-eyed Susans. I love those plants too, but don't be afraid to try something different. Don't be afraid to put something in that you might have to clip some runners on, because you're going to get a lot of enjoyment out of watching the pollinators, out of seeing it fill in your garden so that you don't have all of these bare spots. So just, you know, look at these and try something different. Be curious.
Hello, my name is Rachel Barlock. I'm a water resources engineer at the Southeast Michigan Council of Governments, and I am here today to talk about our climate resiliency and flooding mitigation study. Before I dive in, I just wanted to give a quick overview of what I'll talk about today. First of all, who is SEMCOG? If you're unfamiliar, I'll kind of break it down. I'll talk about the project background, our flooding risk tool, and some of the results. So first of all, who is SEMCOG? I mentioned it's the Southeast Michigan Council of Governments. We are a regional planning agency in Southeast Michigan, and we cover the 7-county region highlighted here. We do a ton of different types of work. So if you're unfamiliar with us, check out our website, semcog.org. We do a lot of regional plans for the area, and it focuses anywhere between water resources, which is my familiarity. We do a lot of planning for transportation assets, economic development, a lot of different types of work that we do at our agency. But I'm going to focus on our climate resiliency work, which ties into transportation and water resources. So I mentioned that we do a lot of different types of plans at SEMCOG. One of the plans that was released in March of 2018 was the Water Resources Plan for Southeast Michigan. So that plan talks about a lot of different goals, policies, actions that we can take to protect our natural resources, like our source water, our drinking water, but also the underground infrastructure. And one of the policies in this plan is to enhance community readiness for changing precipitation patterns to ensure resiliency of our infrastructure and natural resources. So this is kind of just starting to touch on the climate resiliency work that we're doing. We developed that as an action, and then we started working on it. So some of you may remember in 2014, in August, we received a pretty crazy storm event. 6 inches of rainfall in an 8-hour period, which is so much. That was declared a federal disaster. We got about $1.8 billion worth of damages in our region. You can see in this picture, this is a depressed freeway that's, the water is up to the top of the depression. So how do we address this, and how do we plan for the future? There's a study between Michigan State University and the University of Michigan that estimates that annual average rainfall is only projected to increase. So by 2050, mid-century, which is now only less than 30 years from now, we expect rainfall to increase by 7 to 10%, and then upwards of 13 to 23% by the end of century, 2100. And as part of this study, we have been working to kind of update those rainfall estimates and figure out, like, how is one extreme compared to the other? How do we plan for this? We don't want to overplan and spend a ton of money expecting that we're going to get these crazy rainfall events more frequently, but we definitely don't want to keep going as we are, because a lot of our infrastructure is old. and wasn't designed for the frequency and the intensity of the rainfall events that we're receiving now. So that's kind of the basis of this project. So what did we do? Basically, how transportation planning works in a very simplistic explanation is that we take a look at our condition. The condition of the roads are updated annually as far as the database. The Michigan Department of Transportation, MDOT, looks at that, and SEMCOG is one of the agencies that's involved in rating the condition of the roads. So we know approximately what condition all of our roads are in, and how we want to prioritize the areas and improve the condition of the roads by replacing them or resurfacing, for example. And again, this is a really simplistic explanation. I'm a water resources engineer, not a transportation planner, but I'll do my best. So one thing that isn't considered currently is the risk of flooding in that planning process. That's not one of the things that's looked at. And so MDOT asked us to lead this study to figure out how we can start to incorporate flooding risk into project planning. How can we also take that into consideration? Another indicator that can help them prioritize how to spend the limited funds to improve our transportation assets. So what we did is we looked at 4 asset types: bridges, culverts, roads, and pump stations in the SEMCOG 7-county region. And we looked at an analysis that specifically identified flooding risk. There's a lot going on in this slide, but basically here's how we determined flooding risk. We looked at exposure. Was the asset in an area that experiences flooding? So is it a depressed freeway that when water comes, it could potentially pool up and block traffic? Is it sensitive? So that same depressed freeway, if the underground infrastructure, the catch basin where the water goes and drains, is adequately sized, if it's maintained well, it might not be that sensitive, but that is how we estimate sensitivity. How does it fare when it's exposed to rainfall? And those two are coupled together to create vulnerability. And we also look at criticality. So criticality is it the main interstate in our region? Is it a bridge that leads to the only hospital? Or is it a culvert that's potentially, if it blows out, it could take away a road? So criticality was looked at independent of how the rainfall interacts with the asset. And then criticality and vulnerability are coupled together to give us flooding risk. So that was done, and different indicators are used for each of those for all 4 asset types. So like, for example, we looked at pavement condition for the roads, but for the bridges, we looked at bridge condition, which is rated differently than road condition. So that's how we identified the flooding risk. And what we created was this interactive dashboard that's available on our website. It was really designed for transportation planners, stormwater engineers to take a look at this and incorporate this flooding risk into their assessments on their capital improvement projects. So planning out their budgets for the next few years, thinking about how they can incorporate flooding risk as an indicator to determine what's the best project or what's the most critical project for us in the next 5 years, for example. So this map is available on our website. You can toggle through the different assets. This is just a screenshot, but I could do a demo in the future. If you're interested, feel free to email me. And you can check this out yourself as well if you're interested in looking into this further. But you can click on an asset and you can see kind of what went into identifying the risk. So other products, the flooding risk assessment methodology. So all of the kind of behind the scenes stuff that we used, collecting data, figuring out which indicators were important, how can we best identify risk. That's all developed, and we will use that methodology going forward as we continue to collect data and update this map annually each year. The database of risk ratings is something that we have, so that's what feeds into that interactive map. So planners can request that we give them that in an Excel file or a solid map, not an interactive one. We can do that. We have the tool itself, which kind of feeds into this interactive map, does all the behind the scenes calculations. We have a final report and integration strategy. So we worked closely with MDOT so that they can use this in their transportation planning, but we also would like to incorporate this in localized transportation planning as well. So working with communities and counties who also do different types of stormwater planning and transportation work. And then we have the results dashboard, which I showed, and then we're working on a flooding app as well to help the public works departments identify flooding areas and kind of build up a database there as well. So a lot went into this project just to create a beautiful map that's interactive, but we didn't want it to be a report that sits on the shelf. And we really hope that this can help us to start to coordinate projects and incorporate flooding risk, because we know that this is only going to increase as we continue to get more and more intense rain events. So that's kind of a very quick overview of our project. Thank you so much. Happy Earth Day. And if you have any questions, or you would like a deeper dive into this, or you'd like to talk about how you can integrate some of these results into your work, feel free to email me. My email is barlock@semcog.org. And I'm happy to answer any questions via email or give me a call. Thank you so much.